So good morning to all of you. Hope you are all fine at your places. Today we will discuss about the optimum design of a transformer. See, in the last few lectures we were discussed about the main dimensions of the transformer, the winding details of the transformer, and the frame design of the transformer. So in our previous lectures we were see that how the transformer can be designed. If you considered, if you noticed about the magnetic frame or the overall dimensions or the main dimensions, and after that we were discussed about the winding details, and in the winding details you were discussed about that we first of all we have calculate the turns on the low voltage side, turns on the high voltage side, then current on low voltage, current on the high voltage, and after that area. And after that we were discussed about the frame design, and in case of a frame design you see we have to calculate the length of the frame as well as the height of the frame. Now the today lecture, what we have to do, we have to design the transformer for optimization. Now before discussing this optimization, let we have to discuss what do you mean by this term optimization. Optimization क्या होता है? The optimization terms mean by using limited resources you are getting a maximum output. So I am again repeating to you people that optimization means minimum input, maximum output. Clear? So you can say that normally what we have to do, we have to design the transformer without any optimization. We are not using any optimization technique. We are just simply design the transformer, and when you design the transformer you see we have to calculate its ET, then AI, then AGI, then phi m, then AW, HW, WW, AY, and all that. Now what we have to do, we have to design the same transformer, but now today we were discussing about optimization. We are adopt optimization technique. Optimization, as I had already told you, by using minimum resources you can get a maximum output. So with the help of minimum resources, how you can get a maximum output, that you have to discuss in this today's lecture, that is called as optimum design of the transformer, and sometimes it is also called as optimization of the transformer. Now as it is write down that optimum design of a transformer will be carried out by the four following purposes. So means when you have to optimize the design, when you have to consider its optimization technique, the following four factors you should be kept in mind. That is number one, for minimum cost, for minimum weight, for minimum volume, and for maximum efficiency. सो कहने का मतलब ये आया कि जब भी हम अपने ट्रांसफॉर्मर की ऑप्टिमाइजेशन करेंगे, जब भी मैं अपने ट्रांसफॉर्मर का ऑप्टिमम डिजाइन करूंगा, सो आउट ऑफ दीज फोर we have to adopt certain techniques, we have to adopt certain formulas. That for minimum cost, what will be the standard procedure for designing of transformer? For minimum weight, what is the standard procedure for designing the transformer? Similarly for minimum volume and for the maximum efficiency, what is the you can say that what is the strategy that you should adopt to calculate the main dimensions for this transformer. Clear? So you should be kept in mind that optimization technique is basically the comprises of the four main things, and these four main things are: number one, the minimum cost; number two is the minimum weight; number three is the minimum volume; and your fourth one is called as the maximum efficiency. Clear? So if I further continue this thing, so these are the certain formulas that you can use in case of optimization technique. That what do you mean by this optimization technique? So here it is write down for minimum total cost, the cost of the iron and the cost of the copper used is remain same. So this is the number one point, that if you constrain the optimization design for the cost, minimum cost, so here the cost of the iron and the cost of the copper used should remain same. For maximum efficiency, the iron losses is equal to the copper losses, or the specific iron losses is equal to specific copper losses, that is pi is equal to x square pc, where pi is called as the specific iron loss and pc is called as the specific copper loss. Number 3, for the minimum weight, capital GI is equal to GC, that is the weight of the iron is equal to weight of the copper. And your fourth one is for minimum volume, the small GI will be equal to small GC, where you can say that the volume of iron is equal to the volume of the copper. So if you have to design the transformer according to the optimization technique, out of these four, minimum cost, minimum weight, minimum volume, maximum efficiency, you are thinking about these formulas, and based upon these formulas you are trying to solve the numerical, you are trying to solve the design point of view. Now in today's lecture, what I have to do, we will take a simple example or simple one numerical, see how the optimization technique can be implemented on this design, and what is the output that we will receive after the optimization. Clear? So I can again repeat to you, today what we have to do, we will take a numerical problem of the design of the transformer. Now this design of the problem we will continue with the help of optimization technique and see the results, that what is the comparison between the optimization technique and the non-optimization technique. Clear? Understood to all of you? Okay, now the Vinayak has certain question, he has raised hand. Yes Vinayak, tell me what is the question.
Sir, what is this specific iron loss and specific copper loss?
Specific iron loss means for a particular, see your copper loss is basically dependent upon the load, and your iron loss is basically the constant loss. So you can say that throughout the transformer there are iron losses, throughout the transformer there are copper losses, but again these iron losses and these copper losses are ultimately dependent upon the weight of the iron, weight of the copper. So specific means at a particular value, particular weight, or a particular something defined as a particular thing. If you not consider the particular, if you not consider the specific, then it is a normal iron losses, normal copper losses that will be occurring in a transformer. But if you categorize on a specific means a particular time, a particular weight, particular volume, particular gross weight, that is at that particular time, at that particular weight, at particular volume, what is the iron loss, it is a called the specific iron loss. And similarly, what is the copper loss, it is a called the specific copper loss. Clear?
Yes, sir.
Yeah. Clear?
Yes, sir. Yes, sir.
Okay beta.
Yes, sir.
Okay, now all of the students to be present there, what we have to do, first of all we discuss this numerical, and after that I will tell you what will be done in this numerical. Now first of all what we have to do, now see in this numerical we have a given data, and this given data is available again from the client. But now this time the client has requested us that you should design the transformer for optimization, that you should design the transformer by adopting certain optimization. And in that case the client has doesn't mentioned us that which type of optimization technique you are required. That means we are basically having the four optimization technique: minimum cost, minimum weight, minimum volume, and maximum efficiency. The client has given a certain input that we have to design this transformer, but here he or she is not mentioned about which type of optimization technique you should follow. Otherwise what will happen in actual practice, that the client is always tell you that the client will also tell you what is basically. Okay, now what we have to do, basically this information will be given by the client, and you see in the client that you are given that q is equal to this thing and all things. So what we have to do, we have to design the transformer on an optimization, and you see that which type of optimization technique you should follow. You see we have a four type of optimization techniques. That is number one will be the maximum efficiency, the minimum weight, the minimum volume, and the minimum you can say that the cost. So what we have to do, this is the information that you see we have to design a transformer, and the transformer is q is equal to 500 kVA, voltage will be equals to 11,000 by 440 volt, frequency is equal to 50 hertz, a single phase transformer, core type transformer. Here the maximum efficiency will be equal to 90% of the full load. This is the condition that is the given by the client, that is maximum efficiency is given at 90% of the full load. Your current density is 2.75 ampere per mm square. Resistivity of the copper is 2.1 into 10 to the power minus 8 ohm meter. Density of iron here is 7.65 into 10 raised to power 3 kg per meter cube, and the density of the copper is 8.9 into 10 raised to power 3 kg per meter cube. See these three values, that is the resistivity of the copper, the density of the iron, the density of the copper, these three values are always remain same. That is, whenever you have to get the optimization, the resistivity of the copper, the density of the iron, the density of the copper, that always remain fixed. Now, for optimization, the ratio of specific cost of the copper to the specific cost of the iron is 4, and the ratio of length of mean turn to the winding to the length of mean flux is 0.5. Iron losses, as I had already tell you, iron losses are called as the constant losses. So these are fixed losses, and the losses will be 1.23 watt. You have to design this transformer for optimization. Okay. Now you can see that we have these data, that is Q is equal to 500 kVA, voltage is equals to 11,000 by 440 volt, F is equal to 50 hertz, and it is a single phase transformer. Now you tell me that you are able to calculate the main dimension from this relation, isn't it? आप लोग इस डायमेंशन से इसकी मेन डायमेंशन कैलकुलेट कर सकते हैं, नहीं कर सकते हैं? You are given Q, you are given voltage, you are given frequency, you are single phase core type transformer. तो आप इसकी मदद से अपनी मेन डायमेंशन कैलकुलेट कर सकते हैं या नहीं कर सकते हैं? दैट इज आप इसका ET, आप इसका phi m, AI, AGI, आप लोग कैलकुलेट कर सकते हैं इसका?
Yes.
You can easily calculate the ना. But now अभी
Yes,
तक
sir.
जो आप कैलकुलेट करते आ रहे हो, this is called as the normal design. Now what you have to do, you now taken this design in optimization technique. You are adopting the optimization technique. Now when you adopting the optimization technique, so you see that after optimization, you see your ET and your K value will change. And when this ET, that is EMF per turn, and K value will remain change, overall dimension of the design will change. So shall we start this numerical on optimization based?
Yes,
Shall
sir.
we start? Okay.
Yes, sir.
Okay. Now for optimization case, this is the number one step. Very first number one step. That is, you have to calculate the copper loss. And the copper loss is given by the formula, that is current density whole square into resistivity of copper upon density of the copper. Now see, you are given that the current density is 2.7 to 10 raised to power 6. Your resistivity is somehow 2.1 to 10 raised to minus 8, and the density of the copper is 8.9 10 raised to power 3. I can substitute this value and I get a copper loss is equal to 7.8 watts per kg. Now you can calculate and tell me either you can get this value or not. Simply substitute the value and tell me the result, whether you got this value or not. Getting the value?
Yes, sir.
Got the value now?
Yes.
Okay. Now the second step, as we all know, that is the iron losses is remain constant. We all know that iron losses are always constant in case of a transformer, and here the iron losses is also given, that is 1.23. So what is specific iron loss? Specific iron loss means you have to multiply this value with 1.2. So what is a specific iron loss? So specific, you can say that iron loss will be equals to 1.476 watts per kg. So here the Vinayak has a question that what is a specific iron loss? Specific iron loss means it is 1.2 into the iron losses that occur in a transformer. So here, what is the specific iron loss? Specific iron loss is equals to 1.476 watts per kg. Clear beta? Have you got this value?
सर ये कैसे आया 1.2?
ये फिक्स्ड वैल्यू है
सर ये फॉर्मूला है क्या?
हाँ जी, हाँ जी, ये फिक्स्ड वैल्यू है। कभी भी आयरन लॉस का अगर आपको स्पेसिफिक आयरन लॉस निकालना है, ये वैल्यू हमेशा फिक्स्ड रहेगी आपकी, ऑलवेज। आयरन लॉस जितना भी होगा उसका मल्टीप्लिकेशन 1.2 के साथ करेंगे तो आपको स्पेसिफिक आयरन लॉस मिलेगा। ये दैट वैल्यूज रिमेन ऑलवेज फिक्स्ड, यू कांट चेंज दिस वैल्यू। फाइन। ओके, so either you got a value, you got the value or not, tell me na.
Yes.
So you can say that your specific iron loss will be equals to 1.476 watts per kg. And similarly, what is your specific copper loss? The formula for the specific copper loss will be, you have to multiply it by 1.1. See, in case of specific iron loss, you have to multiply it with 1.2. And in order to calculate specific copper loss, you have to multiply it with 1.1. So now you can calculate what is the specific iron loss. Specific iron loss will be equals to it will be equals to 1.476, and a specific copper loss is equals to 19.58. It is clear to all of you? Now you can get an idea that is how this iron loss and this how is copper loss can be calculated, how this specific iron loss and how is specific copper loss can be calculated. See, I am again repeating one thing to you. First of all, for optimization design, you have to calculate the iron loss, you have to calculate the copper loss. Since the iron loss is a constant loss and it will be always given in the numerical, so you have to calculate the specific iron loss. And for specific iron loss, the value will be 1.2 into iron loss. Now for copper losses, what you have to do, the formula will be current density whole square into resistivity of the copper upon density of the copper. So when you calculate this value, you are getting a value of copper loss. So when you get a value of specific copper loss, what you have to do, you have to multiply this value with 1.1. So question is, what is specific copper loss? Specific copper loss means it is 1.1 into copper loss. And what is specific iron loss? It is equals to 1.2 into iron loss. So from that relation, you can get a value that is what is specific iron loss and what is specific copper loss. Clear hai yahan tak?
Yes, sir.
Fine. So already I have left time with you people. So I request to all the students, firstly, mark your attendance.